Hello everyone, today I will going to tight column design. So here is the question of the tight column. The interior column as shown figure of the 5 stories office building. Here is the figure. This building will be 5 stories building is required to design. Okay, the building is constructed with a flat plate slab. The dimension of flat plate panel surrounding the columns are shown in the figure. Here is the 8 meter, 8 meter, 8 meter, and 8 meter, 8 meter into consequence. Here is the 4 panel in x direction. In the same way, y direction is 8 meter. So thickness of all slab panel are 250 millimeter, including floor finishing, and the livelihood of office building 2.4 kN per meter square, and random wall load is 3 kN per meter square. Assume data are required to column as tight column. Assume the required data to design the column as tight column. As we'll design the tight column. So let's start. At first we have to complete the step 1, which is design load. We will find out the slab thickness. Here the slab thickness equal to ln by 30, where ln means the long span of the slab, and divided by 30 is 8, and we have multiplied the 1000, which goes to the millimeter, and divided by 30, so 260 millimeter, and we will provide 250 millimeter. Okay, so we will get the slab thickness 250 millimeter. Even though the question is given the slab thickness is 250 millimeter, here where I can see here the thickness of the slab is 250 millimeter, but we have calculated here. Okay, so the dead load will be the self weight of slab and floor finishing and random wall. So self weight of slab, we will define thickness into unit weight of concrete and tributary area and number of stories. So at first we will calculate the self weight of slab. So here is 250 is the thickness, and 24 is the unit weight of slab, and 8 into 8. 8 into 8 means the tributary area. The tributary area means the column is taking the load from this slab, half of this slab and half of this slab. So here is the 4 meter and 4 meter, so total 8 meter. In the same way, the x direction on the column will take the half of this slab and half of this slab. So it will be 4 meter and 4 meter, so 8 meter. So the column will take this area. That's why we will use 8 meter and 8 meter. And 5 is the number of stories. We will calculate the bottom stories of the column. So the question is given here, the 5 stories building, the column will be designed. That's why we will use 5. In the same way, we will use 50 divided by 1000. 50 means 50 is the thickness of the floor finishing, and 24 is unit weight of concrete, and 8 into 8 means the tributary length of x direction, and another 8 into tributary length of the y direction, and f is the number of stories. 5 stories building, and that's why you will use 5. And the calculation of random wall 3 kN per meter square is given here, or we will take this from various codes such as ACI 31808 or ASC 707 or BNBC 2020 or other codes in your local code. And 8 into 8 in the same way tributary area. 8 means the x direction length and y direction slab length, and we will use 4. Note that we have used here the slab self weight of slab 5, and same way the floor finishing of the slab 5, but in the random wall we will use the 4 because of the when we can construct the 5 stories building. So we will all the building 1 2 3 4 5 So all the internal stories we can use the slab and four feet. But in the other hand, we will see the random wall. At the top of the slab there will be no random wall, and at the top or roof. That's why we will use four, and we will get the 3072 kilonewton. There is a dead load and live load. It will be here because I have forgotten to write in here. That's why we will I have writing here. Live load equal to 2.4. 2.4 is given in the code or given in the question here. 2.4 the live load. It will be taken from the code, which is ASC7 or ACI 31808 or BNBC or other local code. 2.4 kilonewton per meter, 8 into 8, 8 into 8 tributary area of the slab, and divided into 5. 5 means the number of story. So we will get 768 kilonewton. And PU, the ultimate load or design load, will be 1.2 dead load in plus 1.6 live load, which is 4915.2 kilonewton. Okay, step 2, we will assume the column size. So we have used PU equal to 0.65 into 0.80. We will use this factor because we will use the tight column, and 0.85 FMC SG. This is the only force of the concrete. So we will assume the column will take only concrete, not steel, because we will assume the column size. That's why we will use this only for concrete forces. And putting this value, and we have found the area of column size in 3706779 millimeter square, which is 609 into 609 millimeter. We have found this, but we will not provide this this section because we have just assumed the all forces will take in the taken only concrete, but we know that the column will the force will take also steel. So we have used this only the concrete and found 609, but that's why we will reduce the section and assume the value approximately 500 into 500, because we will assume that this force is only taken the concrete. On the other hand, we know the column will be taken also, the force will be taken also concrete and steel. That's why we will reduce the section. Okay, so let's see, this will be 50 into 50 millimeter square. We will assume this. So calculating reinforcement AST, which we will use the tight column formula, which is P equal to 0.65 into 0.80, 0.85 into FMC AG minus AST plus FY into AST, and we will putting this value. F prime C we have assumed the 30, and Fy we will taking the 420 MPa on Newton per millimeter square. Note that we have found 4915 kilonewton, and we have multiplied 1000, which is the force is converted to the kilonewton to Newton, because of we have used for 120 MPa or Newton per millimeter square, or 30 MPa Newton per millimeter square. That's why we have multiplied 1000 or 10 to the power 3. So we have found AST equal to 7820 millimeter square. This is the steel area, and we have checked the rho value. Rho equal to as steel area divided by area of column, and we have found 0.03, which is between 0.01 or 0.06. As we know, the minimum rho is 1%, and maximum rho is 6%. How we'll get this? This is taken from code as SSC 705 or ACI 318 or BNBC or our local or other local codes. Okay, so we have found 0.03, which is greater than minimum value and less than maximum value, so we can say that the row value is okay. Okay, let's number 4. Step 4 is reinforcement detailing. We have using 20 milli ms bar for main bar. So the area of 20 milli is pi into d square by 4, which is 314 millimeter square, and number of bar will be reinforcement divided by used reinforcement, which is found 20.90, but we will use the 26 bar. We will always even bar. We cannot take in the 25 as we have shown here 24.90. We can not take in the odd number, rather we will take the 26 or even number. Okay, the spacing of the main bar. So we have seen here the dimension of the column, dimension of 5 into 5 millimeter square. So we have used 500 and 500. We can use here 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So 14 bar has using in x direction, and the rest of bar will have using y direction. The spacing of the x direction 1 2 3 4 5 6. So we have divide 6 in 6 divided by 500. So we have found the 83.3 millimeter per center per center. This is the main bar we have used. On the other hand, we have used the y direction. The spacing will be the space 1 2 3 4 5 6 7, and we have divide the 500 divide by 7 and got the 71 millimeter per center per center. Here is the 71 millimeter per center center by center. Okay, so spacing of tie bar. We have calculated the tie bar. The spacing is 48 into dt. Dt means die of tie bar. Die of tie bar we have used 10. So we have found 480 millimeter center by center. And second S equal to 16 into dm. Dm equal to die of main bar. Die of main bar we have used 20. So we have found 320 millimeter center by center. And the list dimension of the column. List dimension means column dimension. Column dimension 500 into 500. So we have used the 500. And we have taken the minimum value from here. The minimum value of 320. So a 10 millimeter tie bar will be used at the rate of 300 millimeter by millimeter. So if we want to sketch or detail these reinforcement or tie bar, so we have used like this way, this way. So this is the spacing of the tie bar we have used here. So here is the 10 millibar at the rate of 320 millimeter. So this is the spacing will be 320 millimeter center by center. 320 millimeter center by center. Okay, this is the design of tie bar. So we can also extra lecture on the spacing of the hooks or spacing of lateral tie. We can use the leg. How we'll use the leg? So here is the lateral tie and spacing. We have used how to use the leg. So we have taken this from Nielsen books. If we use only 4 bar and the spacing of the 4 bar to bar spacing 5 inch or less than 6 inch, then we will not use any extra leg. So in the same way, we have seen the second figure. The spacing is given less than 6 inch. So the rebar to rebar spacing 5 inch or 150 millimeter. 6 inch means 150 millimeter. So there will be no leg. So in the same way, we have seen the figure 3. The spacing is less than 6 inch or 150 millimeter. so the bar to bar distance 5 inch. In the same way, in the y direction, the bar to bar is less than 6 inch, we have seen here 5 inches, so there will be no lag use. On the other hand, we can see this picture, which is spacing is less than 6 inches. Spacing means main bar to main bar is spacing, is not a spiral bar, so remember it. So this is the main bar. So main bar spacing, main bar to main bar spacing greater than 60 or 150 millimeter, which is 7 inch. We have taken, or we have assumed this 7 inch by 7 inch, so we will use the one leg. Here is the one leg. This is called one leg. This is called one leg. Okay. We have found same way. This is for the six main bar. If we found the 8 bar, 1 2 3 4 5 6 7 8 main bar, and the spacing of main bar to main bar spacing, we have seen here, main bar to main bar spacing greater than 7, then we will use one leg. Here is the one leg. In the same way, on y direction, we have see if we found the 7 inch or greater than 6 inch by 6 inch, then we will use the same one leg. In the same way, we have found the picture in this picture. So we have found the main bar to main bar spacing is greater than 7. That's why we will use leg. Here is the leg. Here is the leg, and here is in the same way the picture. In this picture, we have we have using the leg. Here is the leg. We can found the spacing between main bar is greater than 6 inches. That's why you will use the this leg. And the same way, the last one we have used the use the leg. So today's lecture is in here. For the type column, you can take a screenshot here and here, and the spacing of leg or leg spacing here. So thank you everyone. If you have any question, then ask me here without any doubt. Thank you all.